to just be able to see the PowerPoint instead of the whole video. Any thoughts on that? Maybe not, maybe not a big, maybe not too helpful. Okay. Let's see. And good morning, Keegan and Bailey. Thanks for joining us. Okay, so anyways, happy November. Hope everyone's doing okay after Halloween. Hope you had a good weekend. Let's just start by doing a quick review of what I did on Thursday, what we did in the group on Thursday. And then I want to start today's new lesson. I'm going to try to finish by 10:30, and then we'll stop and have time to do your mastery test together right now. So here we go. So here's one of the word problems from the mastery test last week. Now remember, this is solving quadratic equations using square roots. And a lot of the problems from last week's, from this mastery test, they're just setting up the uh, equation from a word problem. So some of the questions were actually solving it, and some of them were just setting up the equation, not even making us solve it all the way. And this is one of those. So we read through the word problem, and then we do our best to form it into a quadratic equation. Here we go. Ralph bought a computer monitor with an area of 384 square inches. The length of the monitor is, remember, is means equals. I'm going to put an equals there. The length of the monitor is equal to 6 times the quantity of 5 less than half its width. That's a lot. We'll come back to that and look at it again. Complete the equation that can be used to determine the dimensions of the monitor in terms of its width, W. Complete the equation that can be used to determine the dimensions of the monitor in terms of its width. And then we look below, and in Edmentum, this is a drop-down question. So if we click on these drop-downs, we would get different numbers. Let's try to set it up on our own and then see if we could fill in those blanks, so to speak. So first sentence, Ralph bought a computer monitor with an area of 384 square inches. Before I even look at the next sentence, the next information, I'm going to see if I can make sense of the first sentence. A computer monitor, I'm sure you all know, it's kind of like a phone screen. It's basically a flat rectangle surface. So we're dealing with like a square or a rectangle. So I'm going to just make a little sketch of that. Area of a rectangle is side times side, or maybe you've learned it as length times width. So we don't know how long this is. That's an L for length, or how wide this is. But we know that L times W is 384. Because think back to when we first learned about area in earlier math classes. For a rectangle, it's side times side, length times width. So this is the area formula, basically. And that much we know so far. So we can set this business up. L times W equals 384. Now the second sentence. Let's try to make sense of that. The length of the monitor, so L, length, is equal to 6 times the quantity of 5 less than half its width. There's a lot going on here. 6 times, because of this, 6 times, the quantity of 5 less than half its width. Okay, 5 less than half its width. Now, because they're saying it's 6 times the quantity, that's kind of a clue that we want to bundle the next stuff that they say in a parentheses. So I'm going to make a parentheses like this, 6 times my quantity, 6 times that whole number in the parentheses. So what goes in the parentheses? 5 less than half its width. Okay, they're saying 5 less than something, so that's a clue that it's something minus 5, 5 lower. So it's something here in the blank space, minus 5. Now, what is in the blank space? It's half its width. It's not just the width. It's not 5 less than the width, right? It's 5 less than half. So we get something like this, 1/2 times W. So remember, side note, if you wanted to find a fraction of a number, you're just multiplying the fraction to the number. So because they're saying half its width, that's how I know to do 1/2 times W. If they wanted a different fraction, like 3/4 of its width, it would be 3/4 times W. So here's all we really have to work with so far is on the left, L times W is 384. And then my new equation is L equals this equation, 6 times parentheses 1/2 W minus 5. Okay, this is all good. However, none of it is making a quadratic yet. None of it's making something squared. There's no L squared or W squared here, right? How can we get to that point? I'm going to make a box for some new work. We're going to put both of our equations together. Since the second equation is L equals, length equals, I'm going to plug all of this right here. Plug this into or substitute this into L in the other equation. So I'm basically going to take my L times W equals 384, because that's the area, right? The area of our screen or monitor. And then since the other equation is L equals, then I'm going to just drop that in where L is in my first equation. Here we go. So that 6 times the parentheses, that's all L, right? So looking above, my L, this whole deal right there. So what's missing? Well, it needs to be times W equals 384. Okay, it still doesn't say W squared, but hopefully you're seeing that we're only one step away, because what do you see in our equation now? We've got 6 times the parentheses, there's a W in there, times another W. So if we multiply all this stuff together on the left side, we'll have W squared, and that means we'll have a quadratic. So what does that look like? We're going to distribute the 6 into the parentheses. So let's do that. 6 times 1/2 W minus 6 times 5, that's 30. And right now, I haven't multiplied in the outside W yet, right? So let's do this. I'm going to make this a parentheses and bundle it together to show that I still have to multiply that second W. Okay, now there's a little simplifying to do. 6 times 1/2, well, that's 6 over 2. 6 divided by 2 is 3. So 1/2 times 6, that gives me 3W. There's still a W there, minus 30. Now we're going to distribute again. So multiply the outside W into the parentheses finally, and then now we'll be done after this. So we get 3W squared minus 30W equals 384. Okay. Any questions, comments, concerns so far? We talked about this on Thursday. These are tricky because, one, we have to know our different areas and volumes, because a lot of the word problems, we're talking about area or volume. So we had to know area over here, area of like a rectangle. How did I know it's a rectangle? Because they said it's a computer monitor. So if we don't know what that means, that can make it even trickier. Um, so look for those clues as to like what it's the area of, so we can start by setting the first equation up. Then we had to translate the second equation and get this up here at the top. And then we had to plug them together and do all the algebra and like multiply and spread it all out to finally get our actual quadratic down here at the bottom. Now, in Edmentum, we'd have to do the drop downs and find the right numbers. And notice that my answer at the bottom doesn't exactly look lined up the same way as it does on top, but it's okay. We're just going to plug in the right coefficients into the right spaces. So for instance, looking at my answer at the bottom, we've got 3w squared. So that means wherever the w squared is above, I want a 3. So this drop down should have a single 3. Then the next one is the single w. Mine is negative 30. And then notice how above it's already minus. They've got a minus sign right here. So that means look for the like the 30 in the drop down. And then equals 384. That's the first number on the left side over here, 384. Because it's all by itself. There's no w's or w squareds. So they're not asking us to solve it and find the width. They're just saying set up the equation in terms of w, in terms of its width. No questions or concerns? I want all of you who haven't done it already to try this mastery test today. This one is called, just a reminder, solving equations using square roots. Right here, solving equations using square roots is the first one in Unit 4. Do your best. Don't be hard on yourself if you don't pass the first time. Just give it a shot. And let's look at one more real quick. Which equation correctly solves this formula for r? So look below. They give us, I'll write it bigger. It's v equals pi r squared h. So what they're asking us to do is to solve this for r, meaning rearrange it so that it says r equals instead of v equals. Right now it's solved for v. Volume, we want to solve it for r. Another thing is treat pi like it's a number or a coefficient. So we want to just rearrange this so it says r equals. So we just need to get everything away from the r squared, and then we want to take the square root so that it's r and not r squared. So let's do that. So I'm just going to rewrite it, how it starts. Remember, these are all being multiplied. Pi times r squared times h. So step one is to get the pi, the times pi, and the times h to the other side. We want to get rid of those away from r squared. So we're going to divide by pi and divide by h. I'm going to do it at the same time in one step. We have to divide both sides. If you want to divide one side by something, you're going to do it by both sides. So on the right, pi over pi, that cancels, and h over h cancels. On the left, we've got v over pi times h equals r squared. Let me clean that up so you see it. Okay, we're not done. We have to get it to say r equals, not r squared. Remember, those aren't the same thing. So we're going to take the square root of both sides. So square root on the right and square root on the left. The reason we're doing square root, just remember, square rooting is the opposite of squaring. They undo each other. So continuing here, so we've got the square root of v over pi times h, and that equals r. And technically, another thing from Thursday is when you take the square root of both sides, um, what we're really getting is a positive and a negative version. So technically speaking, we would have two answers here. We would have positive square root, and I'll show it below, the negative square root, like this. Because if you squared a negative number, it becomes positive. So that's why there's always two versions, the positive version and the negative version. Now, if Edmentum offers that as an option, make sure to use both, the positive and the negative. I think for this question, it's just going to give you the positive one, the first one I wrote right here. But if it offers both, like a positive of it and a negative, then choose that. Okay. Next, I want to start and look at the new lesson. So this is going to be the second lesson in Edmentum Unit 4. Second lesson. Okay, and it's called Solving Quadratic Equations by Factoring. All right, and before I get going, I want to just quickly check in, make sure you guys are still with me. So if you could just turn on your camera and give me a hello, or give me a chat and say hi. Just make sure you're still with me before I start. I want to know who's here and who's maybe not here since you're so quiet. Delaney, thank you.
I'm here.
Aaron, was that Aaron?
Yeah.
Thank you. Anne Maria, thank you. Anyone else? Bailey. Hi, Bailey. Thank you. Manaya Leja, you two with me still?
Yeah, I'm still here.
You still here? Okay, great. And Miss Leja, are you there?
Yes, I am here.
Thank you. All right, let's get going then. Thanks, everybody. So here's good news. The good news is today, it's really not anything new. We've done this before in Unit 3. So it's kind of a review lesson. It has been a couple weeks though, so just stick with it, and I'm sure it'll come back to you. At least you'll remember seeing it before. Okay, so review with me. Example 1. In Unit 3, we were asked to solve for zeros. We solved for zeros. Zeros of a quadratic. So remember, the zeros are where, if we graph the thing, it's where it's crossing over the x-axis. This spot and this spot. Those are numbers, right? Because that's like a ruler. The axis of the graph are like rulers. So in my made-up example, maybe they're both positive because they're over on the positive side of x, not the negative side. So let's just say this is at 3 and this is at 7. So the zeros in my picture here would be x is positive 3 and x is positive 7. And then we also tried to solve for zeros without making a picture at all. To do it without a picture, to do it algebraically, it goes like this. We would be given the equation, something, for example, like this. Y is equal to x squared minus x minus 2. Just a nice, small, pretty clean quadratic. So how we solve for the zeros, would be starting by factoring like we have been doing this whole semester. So we make our lists. We say, what is A, B, and C? A here is 1. B is -1 because it's negative x, so that's -1 coefficient. And then C is -2. And then we make our list with those numbers. So we want to make the list that multiplies to A times C. And here that's 1 times -2, so -2. And then it has to add to whatever B is, and that is -1. So the numbers that multiply to -2, remember if we're dealing with a negative, multiplies to a negative, start by making your list with just the positive numbers. One of those numbers would have to be negative. So to make a 2 with multiplication, it's got to be 1 times 2. There's no other option. 1 times 2. Then the question is, well, which one of these numbers is negative? So that when we add them, it makes a -1. So try both like mixes. So I'll show you what I mean. So -1 plus 2, that makes a +1. -1 plus 2. Switch the negative sign. 1 minus 2 now. That makes a -1. Bingo. So that means we want the 1 to be positive and the 2 to be negative. Now, remember what we do when we find the right mix like we just did? We split up the middle term. So back on the left, we're going to split up that -x into a plus 1x, or just plus x, minus 2x. So all I'm doing is taking my original equation and I'm rewriting -x into 1x minus 2x. And then we factor the first group and the second group. So the first group, all we can take out is x. Remember to write down what's left over from those terms after you factor out the single x. It's x plus 1. On the right side, I can take out -2. They each have a nice -2 there. So I take out -2, and what's left is x plus 1. Then our final step is factoring out the parentheses. The parentheses match x plus 1, x plus 1. So we imagine if you pulled that out, what's left over? X minus 2. So here we go. We have x minus 2 left over, and we pulled out our x plus 1. We just factored the quadratic. Now we haven't found the zeros, but we take those parentheses, x minus 2 and x plus 1, and I'm running out of space, so over on the left, I'm going to continue. Right here on the left. Each one of the parentheses is set to 0 and solved for x. And that's where the zeros come into this. We're setting the whole thing equal to 0. So imagine if we said x minus 2 is 0. Well, what does x have to be? It has to be a positive 2. And there's one of the zeros. Now, x plus 1 set equal to 0. Here, it has to be -1. If we solve this guy backwards, we get x is -1, and there's our second answer. So we've done this before, in I think it was Unit 3, solving for zeros. And that's what we're going to do today. This whole new mastery test, solving quadratic equations by factoring, is more of this. However, there will be fraction answers and a little more complex, complicated quadratics to start with, but the process is the same. Now it's already 10:30, and I wanted to show you at least a couple examples. So let's do a couple, and at 10:40, we'll see if we can stop and start our mastery test. And if not, we can just continue and do more examples. All right, so here's our example 2. Solve the equation for x. Okay, sorry, I got a chat here. Yes, go ahead. Of course, just go ahead and go. And I don't mean to put anyone on the spot, but it's all good. Just go ahead and go. If you ever need to go to the restroom, just go for it. Solve the equation for x. And what are we doing? It's going to be this. 2x squared minus 7x minus 15 equals 0. So this is new for us when they're giving us the quadratic and it's already says equals 0. But really all we want to do is factor the part that looks like a quadratic, get it down to the two parentheses, and then set each one equal to 0. It already is right here, set equal to 0. And then we're just solving for x. Okay, so since this is a slightly more complicated looking one, it has a 2 for a right here. A is 2. Then first step for us should be looking at all the other numbers and saying, can I divide those all by 2? That would make it cleaner to start with. It doesn't work though, because b is -7 and c is -15. I can't, those are not divisible by 2 with a whole number like answer. So we're going to have to do this using the 2. So we want to make our list of numbers that multiplies to a times c. And that is 2 times -15. Which is -30. So numbers that multiply to make 30 basically. And then we'll check that against the ones that add to make a -7. That's b. All right, here we go. Make the list. Always start with 1 times. 1 times 30. 2 times 15. 3 times 10. Question? Okay. 4 does not work. I forgot to bring my calculator, but if we divide 30 divided by 4, we don't get a whole number. So we can skip 4. 5 times 6 works. And now we've reached the middle of the list because 5 and 6 are really close. And if we continue, we get 6 times 5. And once you get a repeat, remember, you can stop there. So we don't need to continue our list. And now you're looking at the numbers in your list and saying, well, if I made one of those numbers negative and I started adding things together, which one has a difference of 7? So 1 and 30, that difference is 29. It's too big. 2 and 15, that difference is 13, too big. 3 and 10, though, that's the one because the space between 3 and 10 is 7. So now, next question, which one is negative? So 3 minus 10 or -3 plus 10? And it's the first one. 3 minus 10 gives us that -7. -3 plus 10 below is positive. So we want to make our 10 negative, our 3 positive, and we use this info to split up -7x. So back to our equation. It's going to become plus 3x minus 10x. Minus 15 equals 0. And now group the first two and the second two and factor separately. The first two, I can't pull out a 2 from each term, nor can I pull out a 3 from each term. I can only pull out a single x. So that's what we'll do. And if I divided those each by x, we're left with 2x plus 3. Now on the right side, -10x minus 15. This time I can pull out negative from each one. That's good. And I can divide out 5. 10 is divisible by 5. 15 is divisible by 5. So we're going to divide out -5. Because they're both negative, we're pulling out negative from each. All right, and what's left is 2x, and then -15 divided by -5 is a plus 3. Side work, or in my head, I did this, -15 divided by -5, and that gives me a positive 3, and that's where that positive 3 came from. And now my parentheses are equal. Awesome. So I'm going to pull that out. I'm going to factor out the whole parentheses. 2x plus 3 times the leftovers, x minus 5, equals 0. Okay, so now we're almost done and ready to solve for x. Set each of these parentheses equal to 0, because we're saying x has to be a number. And when I plug it in and multiply it to the other parentheses, it equals 0. Let's start with the harder looking one, 2x plus 3 equals 0. And now we solve the mini equation for x. So minus 3 from both sides. So 2x is equal to negative 3. And then we divide by 2, and we're done. We get x equals negative 3 halves. Oops, we get a fraction. But that's legitimate. It's still a number. It lives on the number line on the graph. That must be where our picture here is crossing the x-axis. Now for the second parenthesis, so to the right, x minus 5 is equal to 0. X is positive 5. And there's our second 0, or our second solution. I hope you're seeing that the process we did is the same as normal. It's just that we had a fraction answer. And when we get to the parentheses stage right here, when we get right here, we have a clue that we're going to have a fraction answer because we have 2x plus 3. Because that the x has a coefficient. That's not 1. So whenever we have this case, this means we're going to have a fraction answer or a fraction solution for x. So it's kind of a clue before we get to the actual answer. I'll leave this up for like 10 more seconds, and then I want to try another example. Any questions, concerns, comments? Please. All right, finish up your notes. If you really need to, just go ahead and take a picture of it. And I'm going to move on. Example.
Wait, so for the 2x plus 3 equals 0, and then you subtracted the 3.
Yes.
Wait, where did you get the 2x over 2?
Good question. Right here, let me see. Where did this come from? Because let me back it up. Let's see. Up here in red, let's start that part over. 2x plus 3 equals 0. Remember, the mini goal at this stage is like getting x alone, getting rid of that times 2 and getting rid of that plus 3. So we work from farther away from the x and get closer each step, meaning I'm going to get rid of that plus 3 first step. And that's why we did this. And then we're left with 2x equals negative 3. So then it's like, I want to get rid of that times 2. How do we undo timesing 2? We have to divide by 2. And you do it to both sides.
Oh.
Is that okay?
Yeah.
Okay. I guess the shorter answer would be we had to divide by 2 because the problem came with a times 2. So we wanted to undo that.
Right.
Okay. Great question. Thanks, Aaron, for asking. Any other comments or questions? Let's try another one. It'll be similar to what we just did. So example 3, same direction, solve for x. Solve the equation for x. I noticed in this mastery test, they're not even calling them solve the quadratic equation. They're just saying solve the equation. Same business for us. Here it is. It's 3x squared plus 11x minus 4 equals 0. So our steps is make the list of A times C. We want to split up our B middle value. We want to factor the two terms, left terms, and then two right terms. And then we do our two mini equations at the end, solving for x, and we're done. Okay, so for our list, can I divide everything here by 3 and get a whole number answer? No. Why would I want to do that? To make it cleaner. If I could divide out 3 from all these terms, that would make it smaller and cleaner and faster to solve. But I can't, so we're going to have to use the 3. So our list of multiplies to a 3 times negative 4. And that makes negative 12. So things that make negative 12, and then it has to add up to an 11. Add to B, that's 11. All right, so 1 times 12, 2 times 6, 3 times 4. These are all the numbers that multiply to make a 12. And then since 3 and 4 are so close, we're done because the next would be 4 times 3. So we can stop our list. And looking at this, the differences in the spaces between 1 and 12, 2 and 6, we want it to be a positive 11. So it's going to be the first set of numbers because 1 and 12, the space between is 11. And let's see. We also know that they're multiplying to make negative 12. So that means one of these numbers, factors, 1 or 12, has to be negative. So negative 1 plus 12 or 1 minus 12. Which one gives us what we want? Positive 11. The first set, negative 1, positive 12. Negative 1, positive 12. So I'm going to put that here in my multiplication just so I remember. And then I go back to my actual equation and we split up 11x. Let's make it negative 1x plus 12x minus 4 equals 0. Now, I included the negative 1. Usually, we should also be used to just writing it as negative x. Negative x, but same thing as negative 1x. Okay, separate the front two and the back two, and then factor those pairs. The front two, we can definitely take out x, and that's it. We can't divide 3 from both, and we can't divide negative from both, so let's just take x. We're left with 3x minus 1. The second set, the back two, 12x minus 4. Well, I can't take x from each, but I can divide 4 from 4 and from 12. So we'll take out a plus 4. And then what's left over? Hopefully it's 3x minus 1. Hopefully it matches our first parentheses. 12x minus divided by 4 is 3x, and then 4 divided by 4 is 1, so minus 1. Very good. And we divide out our parentheses. Oops, it's supposed to be minus. 3x minus 1. And x plus 4 is left over in its own parentheses. All right, there's going to be a fraction answer because I see 3x minus 1 instead of just x minus 1, right? So it's going to be something with a 3 in it, a fraction with a 3 in it. So to figure that out, we're going to take the whole thing and set it equal to 0. 3x minus 1 equals 0. And just like last time, we're going to 2 steps and solve this for x. So we add 1 to the left and the right. 3x equals 1. Divide both sides by 3 and we get x is 1/3. And the faster one will be x plus 4. You've probably already figured out it's -4. If x plus 4 is equal to 0, x has to be -4. All right, I only did 2 examples, but we have 15 minutes left. So I'd like to, right now, have you either start your mastery test, or if you'd like, we can do more examples as a group. So is there anyone who'd like to have me do another one that you could follow along with? Or do you want to just start your mastery test right now?
Josiah, I was going to ask if you could do like one more.
For sure. Absolutely, Laser. Thanks for telling me. I appreciate you telling me. I'll keep this up for 10 more seconds. Finish up your notes, take a picture if you need to, and we'll do another one. If you're feeling ready to start the mastery test, the problems will all be just like these last 2. So go ahead and start that mastery test. This is the second one in Unit 4. Solving quadratic equations by factoring. And I'm going to do another example here. Example 3. Oh, I might have messed up the numbering. I'm sorry. Anyways, this is the next example. Let's try one with all positives. Solve for x. 15x squared plus 65x plus 70 equals 0. Huge numbers. Now, check and see if you can divide everything by 15. Let me grab a calculator. Okay, so 65 divided by 15 doesn't work. It gives me 4.3. And nor can I divide 70 by 15. However, we can actually divide all these terms by a smaller number. I think we can divide everything by 5. So sometimes that will work, and then that'll help us clean up the problem, make it smaller. So let's start by dividing everything by 5. So 15 divided by 5 would be 3x squared. 65 divided by 5 gives us 13, so plus 13x. And then 70 is 14, plus 14. This is much more appealing to me to factor, smaller numbers. And now we've divided everything by 5. Technically, what we just did was factor. So here's what's happening with that 5 we pulled out. I'm going to make a bracket, same as a parentheses. We just factored out 5 from each term. Remember, we're pulling out what's common, that times 5. Now, what happens to the 5? Well, if I were to divide this equation on the left by 5 and the right by 5, what happens? On the left, we have 5 over 5, and they cancel. So it's gone. And on the right, 0 divided by 5 is 0. So when we factor out a common number from all the terms before we start, when we're able to, like this time, it goes away completely. And that's great news for us. So we have 3x squared plus 13x plus 14 equals 0. Okay, now we begin our game of making a list and splitting up b and factoring. So 3 times 14. It's 42. So we want to make a list of things that make 42 multiplies to 3 times 14, 42. Adds to 13. Okay, so start when you're making your lists. I think it's easiest to always start with 1 times and then 2 times and make and with increasing numbers. So 1 times 42 and then 2. So I don't know it off the top of my head, so we divide. 42 divided by 2 is 21. So 2 times 21. And 42 divided by 3, try that. 14. Try 4. 42 divided by 4. Okay, that gives me a decimal, so I skip the 4 times. How about 5 times? 42 divided by 5. Another decimal. 42 divided by 6 gives me 7. So we skipped 4 times and 5 times because they gave us decimals, but 6 times 7 works. And see how close those are? That's like the middle of our list, so we can stop there. Now, this time, it's a positive 42, and they add to make a positive 13. So good news, we have both positive numbers. So we're not doing a subtraction this time. There's no negatives. It's all positives, meaning they have to add to make a positive 13. So like, for instance, 1 plus 42, that doesn't work. That's too big. And 2 plus 21 doesn't work. Too big. That's 23. 3 plus 14 is 17. And then finally, 6 plus 7 is 13. That's the one that adds to make a 13. So we found the right numbers. So we're going to split up B using 6 and 7. So our 13 becomes 6x plus 7x. All right, and we're back to work after all that side work. Now we can finally do the factoring. Okay, so on the left, I can always pull out an x from the first two. Remember that. We're always taking out a single x. However, we can also divide out 3 this time. We can take out 3 and we can take out x. So we divide out 3x and we're left with x plus 2. The right two numbers, I can't take out x, but they're both divisible by 7. So we're going to divide out 7 and we're left with x plus 2. And now we divide out the parentheses, so x plus 2. What's left over? 3x plus 7 is left over. And that all equals 0. And now we can set our two parentheses equal to 0 and find the fraction and the whole number answer. I'll do this on the left, where there's some blank space. So x plus 2 is 0, minus 2 to both sides. X is negative 2. Sweet. Now for the slightly more complicated one, it's 3x plus 7 equals 0. So always get rid of the plus or minus number first. So we're going to do minus 7 to both sides. We get 3x equals negative 7. And of course, we have to undo that times 3 by dividing 3. So we get x equals negative 7/3. And finally, we've solved it. So for these last 3 examples for today, they've all had like one whole number answer and one fraction answer. I have one more example where we end up with 2 fraction answers. The work is the same. We're going to make our lists, split up B, factor the front 2 and the back 2, And then finally, set each parentheses equal to 0 and solve for each x. And since we've only got a few minutes left, I'm going to just do our final example. And then I'm going to let you go for today. If you haven't done Thursday's work, which was the first mastery test in Unit 4, I want you to attempt it today. Just give it your best shot. It's a tougher one because it's a lot of word problems. If you need a refresher, you can see the video on YouTube or you can try the tutorial. Then I want you to do the second mastery test today as well. That's for this stuff that we've done this morning. Let's look at our final example. And forgive me if I've messed up the numbering. I'm not sure if I did. Example 4, solve for x. Here's our equation. 40x squared minus x minus 6 equals 0. Okay, this time we've got a huge A and relatively smaller B and C numbers. I can't divide out 40 from -1, right? Or from -6. So we have to just use the giant 40 number that we started with. So the numbers that multiply to 40 times -6, yikes, what is that? 40 times 6, 240, -240 really. Okay, but we can do it. It just takes a little more time. And then it adds to a -1, the B number in the middle. Here we go. 1 times 240. 2 times 120. Try dividing 240 by 3. 80. So 3 times 80. Now remember, look at my list that I've got so far. If we're doing it correctly, then we should see our numbers increasing on one side, 1, 2, 3, and then they're decreasing on the other side, 240, 120, 80, and they're getting smaller, right? And they're going to meet in the middle. And that's when we can stop with the list. 240 divided by 4 is 60. 240 divided by 5 is 48. And remember, we're looking for them to, it's a negative this time. There's negatives involved. So we're probably going to have one of these numbers is negative, one is positive. And when we add them together, we're going to have a space of just 1, right? -1. So we need to find the middle of our list. All right, 240 divided by 6 is 40. And since 6 and 40 are still really far apart, we got to keep going. 240 divided by 7 does not work. 240 divided by 8 works, so 8 times 30 is 240. 240 divided by 9 does not work. 240 divided by 10 is 24. We're getting there. All right, 240 divided by 11 probably is not going to work. Nope. 240 divided by 12, 20. That's good. We're getting close. 240 divided by 13. That's not going to work. Let's try 14. Nope. 240 divided by 15. Oh, sweet. 15 times 16. And check it out. They're only one apart from each other. So we're going to use this one. We know that because they have to add to make a positive or -1. So that means the space is correct. Try adding both, changing the negative around, and which one gives us a -1? -16. -16. I'm running out of time. I think we need to go. What we would do next is split up that middle -x. It doesn't look like we're splitting it up. We're technically rewriting it, right? We're making our -x into a plus 15x minus 16x. All right, I'm not sure what time it is. My clock, I think, is slow here. So I think it's time to go. I'm sorry I didn't finish this, but I'm going to let you folks go today. If you want, why don't you try finishing this example on your own? We'll start with that tomorrow. Try your 2 mastery tests if you haven't done them already.